All right, so last time we met, we introduced a new kind of compound called an acid. Do you remember anything about an acid?
It dissociates.
Very good. Dissociates, that's right. And when it
And then it goes
dissociates,
right back.
some weak acids go right back. That's right. Acids, when they dissociate, what is it that they release? If this is going to dissociate, what ions will it release?
H2, wait.
H plus ion, remember? And Cl minus ion. When this dissociates, it's going to release an H plus and a Cl minus. Okay? Does that make sense?
Yeah.
And another way that people sometimes like to write that is to write HCl with a water molecule. And then the H plus that comes off here, it goes with the water molecule to form H3O plus. And then we still end up with the Cl minus left over at the end. Can you see how those are both the same thing?
Yeah.
Okay, very good. And then, like you mentioned, some are weak acids. Some acids are weak acids. And if I made an example of a weak acid like AHX, and now acids, you can generally recognize them because they begin with a hydrogen. But if this is a weak acid, I would want to have two arrows to show that the dissociated products can go back to form that material. And those two arrows are a sign that it's a weak acid. Okay?
Okay.
All right. So an acid is a molecular compound that dissociates like an ionic compound and releases an H plus ion. Now, there's also a compound called a base. A base is a compound that when it dissociates or when it goes into water, it doesn't release the H plus ion, all right, the H plus ion, but it releases the other half of the water molecule, which is a hydroxide ion, OH minus. Can you see that if I have OH minus and H plus and they come together, can you tell what will form?
Water.
That's right, water will form, H2O. So an acid is a compound that when you put it in water, it releases the H plus ion. But a base is a compound that when you put it in water, the hydroxide ion is formed. Okay, that's acid and bases. Okay, so strong and weak doesn't mean like this acid is strong, it'll kill the joker, or this acid is weak, you can drink it. It's not that kind of a thing when we talk about strong or weak. When we talk about strong or weak, it tells us we're telling somebody how much dissociation will occur on the acid. All right. So if I have a strong acid, it means it completely dissociates. You put it into water, they separate, they never come back together. A weak acid, you put it into water and only it'll dissociate for a little bit and then come right back. Okay? And then it'll do it again and then come right back. That's a weak acid. Same thing with strong or weak electrolytes. Electrolytes are, I don't know if you remember, but we talked about electrolytes before. For example, sodium chloride, an electrolyte. You put it into water and these ions result. All right? So these are, an electrolyte is a compound that you put into water and the electrolytes result. Sodium chloride is a strong electrolyte because it completely dissociates. And remember, we had a list here of rules that helped us know whether or not a compound was going to be a strong or weak electrolyte or a non-electrolyte. Remember these solubility rules?
I have a
Yeah.
question. What would it equal if you had all salts containing NH4 are soluble with no exceptions, but what if it has group 6?
Group 6.
What if it has
Group 6.
What if it has PO4 -3 charge?
Yeah. So let's read what it says in group 6. It says all salts that contain phosphorus are insoluble, except those of group 1A and ammonium. You see that? So there is an exception there. So that's a very good question. So this says up here, all salts containing these ones are soluble, but this one says all salts containing these are insoluble, but there's an exception for this one, and it's with ammonium. So you're...
What about NO3?
NO3 is a minus, an anion, so therefore it's never going to be with these other anions. It would only be with a cation, right?
Right.
Okay, good questions. Really good questions. So strong acids, strong electrolytes, strong bases refer to the degree of dissociation. Very good. And to get strong bases, you have to have, looking at our solubility rules, strong bases are ionic compounds that contain the hydroxide ion. So rule 5 here tells us which compounds are strong bases, because ionic compounds that have the hydroxide ion will only be soluble if they are group 1A or calcium, strontium, or barium. All right, so that's how we can know whether or not we have our strong bases. Also, here is our list of strong acids. 1, 2, 3, 4, 5, 7 strong acids right here. And we're going to have to kind of memorize that list of strong acids. Do you have your periodic table with you? Okay, why don't we get your periodic table with you?
No.
And then we'll also have to make sure we write down on that periodic table. So, do you have a pen with you?
Got it.
Good. So on the back side of that periodic table somewhere, make a list, very small so it's not too big, of these acids, these strong acids, because we need a list of these strong acids. All right. Now, to make sure we understand what we're talking about when we talk about strong acids, I have a little cartoon here for us. This is a strong acid, HCl. It's one of our strong acids. And when it reacts with water, the hydrogen ion goes with the water and forms H3O+, like that. And what's behind are these chloride ions. All right? So that is what strong acids do. They completely dissociate. Weak acids, on the other hand, this is the chemical formula for acetic acid. Acetic acid is a weak acid, therefore very little amount of it dissociates, or very small amount of it is dissociated at any one time. Now, when they find each other, they'll go back, and so we want to make sure that when we write a weak acid, we always have a double arrow, a second arrow, showing that these two, the ion here and the hydroxide or the hydrogen ion, will come back together and find each other and come back and form water and the protonated acid. Now, remember how we said that if you put salt into water, it causes the water to become conductive. Do you remember that?
Yeah.
All right. Well, if we put a weak acid into water, it will only cause the water to become slightly conductive. Same thing with a weak base, only slightly conductive. And that's because weak acids and weak bases only result in a very low concentration of ions, because that's why they are weak. They don't dissociate very much. Now we're going to talk about naming acids. We need to be able to name acids. And to name acids, we have to classify our acids into two different groups. There's two different groups of acids. One group is called binary acids. A binary acid only contains two atoms. Only contains two atoms, two different kinds of atoms, hydrogen and something else. So HCl is an example of a binary acid. HBr, binary. HI, that's binary, right? Just two different kinds of ions. All right? And that kind of acid is named following this model. HCl is called hydrochloric acid. So we took the hydrogen and the chloride and we changed it to hydrochloric acid. All right. This model I like to call the hydroblankic because it follows this hydro blank, and you fill that in with the other atom, and you end it with ic, hydroblank ic, and then you say acid. All right. Now this is just for binary acids. All right. The other type of acids are oxoacids, acids that contain oxygen. And oxoacids are acids that have a hydrogen and the rest is a polyatomic ion, like NO3. Do you remember the name of the NO3 ion?
Sulfate?
No? Look on your polyatomic ion chart, NO3. Nitrate ion. Very good. So, if I put a hydrogen in front of my nitrate ion, I get HNO3, and that's an acid. And to name oxoacids, again, acids that contain oxygen, and they're usually polyatomic ions, to name them, the 8 changes at the end of the polyatomic ion. So nitrate changes to an ic. 8 goes to ic. And then it's called nitric acid. Nitric acid. All right? So, if I have H2SO4, what's the name of the polyatomic ion, the SO4? What's the name of the SO4 polyatomic ion? Are you there?
What?
What's the name of the SO4 polyatomic ion?
Sulfate.
That's right, sulfate. So if I put hydrogens on it, I make what acid? The sulfate goes to sulfur what?
Sulfurous.
No, sulfuric. Sulfuric acid. 8 goes to ic. All right. So if we have an acid that ends in 8, the 8 is turned, if we have a polyatomic ion in an acid that ends in 8, that 8 goes to ic, and we call it, whatever the name of the polyatomic ion is, ic acid. If the polyatomic ion ends in ite, then ite goes to OUS. 8 goes to ic, and ite goes to us. So chlorite becomes chlorus acid. All right. So which of the following acids here is going to be named following the hydroblankic model? Oh, sorry. Which one is not named as a hydroblankic model? Okay, so which ones are named using the hydroblankic model? Is it the binary acids or the oxyacids?
Binary.
Binary are named hydroblankic. So which one of these are not binary?
B.
B is binary because there's only hydrogen and sulfur. So that is a binary acid. So it will be named after the hydroblankic, hydrosulfuric acid. So not that one.
All are named in this way.
All? What about HNO3? Is that binary? Or is that an oxo acid?
Oxo acid.
It is an oxo acid. It contains oxygen. It's a polyatomic ion. So that one is not named following the hydroblankic model. What is HNO3 going to be called? What are we going to name that acid? Do you remember?
Hydrogen nitrate.
What? Nitrate, 8.
Oh, nitrate.
Nitric acid. Very good. Nitric acid. There we go. So what about HNO2? What is that acid going to be named?
Hydrogen nitrous.
Very good. But we don't use the hydro. The hydroblankic is only for binary acids. We just take the polyatomic ion, the nitrite, and if it's ite, it goes to us. So it's just called nitrous acid. Excellent. How about HClO4?
Is it phosphor?
ClO4, did you see it on your polyatomic ion chart?
Phosphoric.
ClO4. Look again. What's the name of the ClO4?
ClO4.
Perchloric. Very good. Perchloric. Very good. Perchlorate ion, and 8 goes to ic. So it's perchloric acid. Good. How about HF? HF is a binary acid, isn't it?
Yeah.
All right, so we name it following the hydroblankic model, right? What goes in the blank when we're trying to name HF?
Fluor.
That's it, right, fluor. That's right. So what?
Hydrofluoric acid.
Very good, hydrofluoric acid. Excellent. How about HMNO4? What is that acid called?
Permanganic.
Very good, permanganic acid. Excellent job. How about H2CO3?
Hydrogen carbonic.
Carbonic acid. But we don't need the hydrogen in front, right? Because it's not a binary acid. So just carbonic acid. Excellent job. How about this one here? HClO3? A, B, or C?
A.
A, perchloric acid? Is the ClO3 the perchlorate ion?
Oh, it's chlorate.
Yeah, so which one is it?
C.
C, chloric acid. Very good. H2SO3?
Is it sulfite?
Sulfite, that's the ion. So what is the acid called?
So B.
B. That's right. Sulfurous acid. Sulfurous acid. Very good. So look at all these acids here. Notice that they all start with H, right? It's an easy way for somebody to show somebody that they're talking about an acid when they make a compound that begins with a hydrogen ion. And remember that acids are either strong or weak right now, and we have our list. HNO2, is that a strong or a weak acid? Do you have your list there of strong and weak acids?
Weak.
It's weak. Very good. Are any on this list strong acids?
Number 2.
That's right. Perchloric acid is the only one that's a strong acid. So hopefully you wrote down those strong acids. I'll write them down here for anybody who didn't write them down when you wrote them down. But our strong acids are HCl, HBr, HI, HNO3, H2SO4, HClO4, and HClO3. That's an O. Okay, those are our 7 strong acids for this. You know, you look in different books and some people say that there's 6, so it just depends. And we'll talk in the future about why that's the case, that there's slight differences between them, but strong acids. Okay, so then, I'm going to now write down ways in which our compounds ionize when they're placed in water. Okay, so if we have a chemical that somebody says is a weak base, and this is how a question will generally occur. They'll tell us this chemical, whatever it is a weak base, and we'll need to show how that chemical ionizes when placed into solution. And this is how weak bases ionize. What they do, weak bases, all right, we saw how strong acids ionize, and we saw how weak acids ionize. But we haven't talked about how weak bases ionize. And this is how they ionize. If we have this weak base, CH3NH2, what it does, now remember, a base is a compound that you put it into water, and what comes out? Do you remember? What comes out when you put a base into water?
It comes CH3.
No, it's the OH minus ion.
Oh, yeah.
That's a base. So where are we going to get that from? Well, the way we get it is we get it from the weak base, it interacting with the hydrogen in water. It pulls the hydrogen off of water and leaves behind the hydroxide ion. So can you see how this chemical, CH3NH2, took a hydrogen from the water molecule and put it on the nitrogen there. So now I have CH3NH3 with a positive charge. So weak bases take protons from water, take hydrogen ions from water, and make it the hydroxide ion. Okay? Now, I also want to have a conversation because you might hear me every once in a while calling a hydrogen ion by a different name. So this is a hydrogen ion. A hydrogen ion has, let's go back and do a review really quick. How many protons does this hydrogen ion have?
14. No, 7.
H? Here it is right here.
Oh, 1.
1. That's right. Hydrogen has 1 proton. But the plus sign shows us that it it has done something different with its electrons. How many electrons does a hydrogen ion have?
1.
No, the plus sign means it lost that electron, right? So it has no electrons. 1 proton, but 0 electrons. Okay? So sometimes we'll call the hydrogen ion, another name for it is a proton. All right? Also known as the hydrogen ion. Hydrogen ion. Also, sometimes people will show it like this, the hydrogen on a water molecule, which is called the hydronium ion. All right? But I often will call it a proton because that's what it is. It was a hydrogen atom, but it lost its electron, and so now it's just that 1 proton. Okay? Is that okay? Is that fair?
Yeah.
All right, wonderful. So here we have our dissociation of our weak base. Our weak acid, HNO2, how is it going to dissociate? What do I have to write? How do I write the dissociation of our weak acid, HNO2?
H.
What is it going to dissociate into?
OH.
No, this one is an acid, so it doesn't release OH. What does it release?
H.
H plus, the proton or the hydrogen ion, right? And then what else?
NO2. No.
Very good. Does it have a charge? NO2 minus, right?
Yeah.
NO2 minus. Very good. And then do I have to do something special with the arrows here? What do I have to do to show that it's a weak acid?
Draw one the other way.
Double arrow, right? Very good. Okay, so we have a weak acid. And when they drew the weak acid, when you have to be familiar with this as well, there's a water molecule included. That's how a lot of people like to see it. I prefer to see it like this down here. I don't need to know that there's a water molecule there if something is an ion. I already know that it's surrounded in water. Strong acid, HClO3, dissociates like this, right? HClO3 dissociates to an H plus and a ClO3 minus ion. Or, like with the water molecule, you can show it the H plus ion going on to the water molecule. Now, a strong base, strontium hydroxide, SrOH2. Strontium hydroxide is just a an ionic compound. It's just an ionic compound. And you can see on our, first on our periodic table, strontium, plus 2 charge. And that's why there's 2 hydroxide ions. All right, 2 hydroxide ions with each strontium. I can also see on my solubility rules, right, that my solubility rule number 5, because it's with strontium, it's going to be soluble. And so I just have to write the ionization of this compound. If this compound ionizes, we're going to have the strontium ion and 2 of our hydroxide ions, right? And so that is it's not a weak base, it's a strong base. So that's going to be the dissociation of our strong base. Okay, good job for today.